That's because stamping it's a mechanical process. We are talking about stamping. Use a punch to hit this strip of ours. Carry out a fast and high speed. This cutting pan. Cutting material. Such a cut such a way. So it's a mechanical process. So in the course of this mechanical experiment, therefore, our structure, a large part of it creates a mechanical stress. Is this our stamping part? In our connector products? Or something goes wrong? Or in terms of quality consistency? In terms of stability? It is more prone to some hidden dangers. A very crucial place? Our terminals. And you always have a structure like this, right? It's a structure like this. U-shaped structure. What about this structure? Among our stamped structural parts. Very, very, very common. What about this structure? In the application process of our product, it usually has what we call a rebound. The rebound of this shape. Or rather, in our processing process, due to the particularity of this structure, will appear eventually. Crack. How about these two? It's our stamping part. There are many. A bad phenomenon. How about this one? Of course, there will be some connection with our design. So let's not talk about the design itself here. We only talk about the stamping process. We all know that. Lando ramen, right? How about a lot of us? I will also try to knead this noodle at home. Go kick this noodle. But what about the vast majority of people? I guess it's the same as me. This surface will break as soon as you pull it. But for this true noodle maker, you see, his noodles can enter. Do it several times, dozens of times, hundreds of times. Such a cycle of pulling. Then our metal material. It's the same story. The same reason. Some metallic materials. In some of the experts. Some in the manufacturing field. In the hands of some experts. It can be stretched multiple times. Multiple demolition. Without a little bit of so-called broken. Or some phenomenon like cracking. But what about some materials? Yes, in some manufacturers. After performing this processing operation once or twice, cracks will appear. There will be some phenomena such as damage. What about this phenomenon? How did it happen? In fact, it is still related to the material. What we talked about, flexibility and our processing. Does it conform to the curve of the material itself? Within our range of elastic curvature. And that's what we're going to talk about today. During this tooth fleshing process, how to protect our processing parts. We can always maintain the required characteristic parameters are within this range. That was just said. Our stamping. It's a mechanical process. During the operation of this machine, it causes a shape change. Changes in appearance, the second, will produce them structurally. Microscopic changes. What about this change? Because of the special metal material, this one, parameters of elasticity, this characteristic of elasticity, is that within a certain range? This material can be produced. Permanent reply is that we do something to it. After this machining, within the allowable range, it will produce. It will return to its original state. Then this thing, let's call it this elastic range. This is a very, very important material. A parameter in this stamping of our metal material during processing. This is made by your stamping. Do not go beyond this elastic limit. This is a very crucial bottom line and condition. So we're doing this stretch bending. So this is sort of the design process. When some designs are made, we must pay attention. Our manufacturing process. Has it exceeded its product limit? Or is it a two-step process? Maybe even multiple steps. Take every step. It's within its elastic limits. This is a critical design approach.